The cosmos, vast and infinite, has always captured humanity's imagination. For centuries, we have gazed at the stars, wondering what secrets lie hidden in the deep expanse of space. Our understanding of the universe has grown in remarkable ways, thanks to the advancement of technology, the relentless curiosity of astronomers, and the innovative work of space agencies like NASA. Yet, for all our knowledge, there remains an edge, an unknown boundary that even our most powerful telescopes cannot fully penetrate. The discovery that NASA made recently, far beyond the observable universe, challenges everything we thought we knew about space. It suggests that what lies beyond the universe we can see could be far more profound, mysterious, and potentially unsettling than we ever imagined. The concept of the dark side of the cosmos is not a metaphor, but a real, physical phenomenon, an area of space that has eluded our detection until now. The observable universe, as we understand it, is defined by the distance that light has had time to travel since the Big Bang, roughly 13.8 billion years ago. Everything we know about the universe, the stars, galaxies, black holes, dark matter, and cosmic microwave background radiation, has been based on this observable region. It is the portion of space from which light has had time to reach us. But what if the universe stretches far beyond this, into regions where light has not yet had time to travel, where the laws of physics are different, and where phenomena exist that we cannot yet comprehend? NASA's recent findings hint at the possibility of this very thing. Using advanced space telescopes and other cutting-edge instruments, astronomers have begun to observe anomalies in the farthest reaches of space. These anomalies seem to suggest that the universe is not just larger than we thought, but that the laws of physics may change once you go beyond the observable edge. What NASA has found is a dark zone, a region beyond the universe's edge where matter and energy behave in unexpected ways. The discovery of this dark zone challenges the very foundation of cosmology. If the laws of physics can change at the boundary of the observable universe, what does that mean for our understanding of space-time itself? What happens when we push past the limits of our knowledge and try to understand the dark side of the cosmos? The implications are profound, and they raise questions that have never been considered before. The dark side of the cosmos is not a place of pure emptiness, as one might imagine. Instead, it appears to be a region where the typical rules of physics break down, where the familiar forces of gravity, electromagnetism, and nuclear interactions no longer apply in the same way. This raises the possibility of entirely new forces at play, forces that we have yet to discover or understand. For years, scientists have believed that the universe is governed by a set of universal laws, laws that are consistent across time and space. The discovery of the dark side of the cosmos, however, suggests that these laws may not be universal at all. It's possible that what we perceive as the rules of physics are merely the rules of our own universe, and that in other parts of space, those rules may not hold. This idea, while radical, is gaining traction among some of the most respected physicists in the field. To truly understand what's happening beyond the observable universe, scientists must explore concepts like quantum gravity, dark matter, and dark energy, phenomena that have long puzzled researchers. Dark matter and dark energy make up roughly 95% of the universe's mass and energy, yet they remain invisible to our current instruments. We know they exist because of their gravitational effects on visible matter, but we cannot detect them directly. Could the dark side of the cosmos be linked to these mysterious substances? Could dark matter and dark energy behave differently in the regions beyond the observable universe, in ways that would radically change our understanding of the cosmos? NASA's findings also suggest that the dark zone may be home to objects or structures that we cannot even begin to imagine. Black holes, once thought to be the most extreme objects in the universe, could be just one of many strange phenomena lurking in this uncharted territory. What if there are entire galaxies, or even supermassive black holes, hidden beyond the edge of the universe, too far to be detected by our instruments, but potentially capable of influencing the visible universe in ways we do not yet understand? This concept of the dark side of the cosmos brings to mind the idea of a hidden multiverse, the notion that our universe is just one of many, each with its own set of physical laws. If the dark side of the cosmos is part of a larger multiversal structure, it would suggest that our universe is not unique, but rather one piece of an infinitely complex and interconnected whole. This could mean that there are other universes out there, each operating according to its own set of rules, with its own laws of physics, time, and space. The implications of such a discovery are staggering. If the dark side of the cosmos is a place where the laws of physics break down, it could open the door to a new understanding of space-time itself. What if the nature of reality is not fixed, but malleable, and subject to the forces of an entirely new dimension? Could there be new ways of traveling through space, new forms of energy, or even new forms of life hidden in these regions? For now, these questions remain speculative, but they offer a tantalizing glimpse into what might lie beyond our understanding. As we continue to study the signals from beyond the observable universe, we may uncover new phenomena that will challenge the very foundations of science. The journey to understand the dark side of the cosmos is just beginning, and the answers we seek may forever change our understanding of reality itself. NASA's groundbreaking findings have brought us to the edge of a new era in science. For centuries, we have gazed up at the stars and wondered what lies beyond our view. But now, with the discovery of the dark side of the cosmos, we may be on the verge of a new era of discovery, one that will take us beyond the known universe and into realms that we can only begin to imagine. The universe is far more complex and mysterious than we ever realized, and the dark side of the cosmos may be the key to unlocking its most profound secrets. The discovery of the dark side of the cosmos raises a series of questions that not only challenge our understanding of the universe, but also force us to confront the limitations of our scientific frameworks. The more we explore the edges of the observable universe, the more we realize that the universe is not simply a vast, empty expanse, but a complex and interconnected web of phenomena, many of which lie beyond our ability to measure or comprehend. At the heart of this discovery is the idea that what we perceive as the end of the universe may not be an actual boundary at all. Instead, it could be a point where the very fabric of space-time undergoes dramatic shifts, where the rules of physics break down, and where new unknown forces take control. The dark side of the cosmos is not a place of total darkness, as the name might suggest, but rather an enigmatic region where the usual laws of physics do not apply in the same way they do within our observable universe. But why has this region remained hidden for so long? The answer lies in the fundamental nature of the universe and the limits of our observational technology. As we peer deeper into space, we realize that the observable universe is not static. It is expanding, stretching outward at incredible speeds. The further we look, the more distant and less accessible these regions become. What we've been observing so far is merely the light from stars and galaxies that have had time to travel across vast distances, arriving at our telescopes over billions of years. But beyond that, the light from objects simply hasn't had enough time to reach us, and this creates a kind of cosmic horizon that limits our view. It is within this horizon, just beyond the observable edge, that NASA has begun detecting strange, unexplainable signals. These signals are unlike anything we have seen before. They do not conform to the expected patterns of cosmic radiation, the usual fluctuations in background noise, or any known astronomical phenomena. They suggest that the very space-time fabric itself may be behaving in ways that challenge our current understanding. This discovery has led scientists to reconsider the nature of space-time itself. For decades, the prevailing theory of space-time has been largely shaped by Albert Einstein's general theory of relativity, which provides a framework for understanding how massive objects warp the fabric of space-time and create gravitational effects. According to this model, space and time are interconnected, forming a four-dimensional continuum that is influenced by mass and energy. This theory has been incredibly successful in explaining many aspects of the universe, from the orbits of planets to the behavior of black holes. However, this new discovery hints at something beyond the reach of relativity, a region of space where the known laws of physics begin to break down. This raises a tantalizing possibility. What if the region beyond the observable universe is not just a vast emptiness, but a space where new laws of physics govern the behavior of matter and energy? What if the very idea of space-time, as we understand it, is incomplete? The nature of the dark side of the cosmos could provide insights into the missing pieces of the puzzle, shedding light on the very structure of the universe itself. One of the most intriguing possibilities is that the dark side of the cosmos may be connected to the enigmatic phenomenon known as dark matter. For decades, scientists have known that there is more mass in the universe than we can detect with conventional instruments. This unseen mass is thought to account for roughly 85% of the total mass in the universe, yet it remains invisible to telescopes and other instruments. Dark matter is thought to interact with ordinary matter through gravity, but it does not emit, absorb, or reflect light, making it impossible to directly observe. Could the dark side of the cosmos be a region where dark matter is more concentrated or behaves in ways that are completely different from what we've observed in our own universe? The signals that NASA has detected may be linked to dark matter, offering us a new way to study this mysterious substance. If dark matter is more than just an invisible form of mass, but a component of a larger, unexplored cosmic structure, then it could provide the key to understanding the dark side of the cosmos. Similarly, another force that might be at play beyond the observable universe is dark energy. Dark energy is thought to be responsible for the accelerated expansion of the universe, a discovery that was made just over 2 decades ago. While dark energy is not well understood, it is believed to make up about 70% of the universe's energy content. Some scientists speculate that dark energy may behave differently in regions beyond the observable universe, where it could influence the very structure of space-time in ways that we have yet to comprehend. What we are learning about the dark side of the cosmos could change the way we think about these fundamental forces. If dark matter and dark energy are not simply invisible and passive components of the universe, but active forces that shape the very fabric of space-time itself, it could open up entirely new areas of research. These forces may play a key role in the formation of galaxies, the expansion of the universe, and even the creation of new universes in a cosmic multiverse. But the dark side of the cosmos is not just a scientific curiosity. It raises deeply philosophical questions about the nature of existence. If there are realms beyond the observable universe, does that mean that the universe we live in is just one of many? And if so, what does that mean for our place in the cosmos? Are we just a tiny part of an infinitely complex and interconnected reality, or is our universe unique in its ability to sustain life and consciousness? The discovery of the dark side of the cosmos challenges the long-held notion that the universe is a singular, self-contained entity. If the laws of physics break down at the edges of the universe, what does that mean for our understanding of the nature of reality itself? Does it suggest that reality is not fixed, but rather dynamic, constantly changing and evolving, perhaps even interacting with parallel realms beyond our comprehension? As scientists continue to study the signals from beyond the observable universe, the discovery of the dark side of the cosmos forces us to reevaluate our assumptions about the universe, the laws that govern it, and the very nature of existence. What we learn in the coming years may completely revolutionize our understanding of reality, opening up new fields of study, new realms of possibility, and a deeper understanding of our place in the universe. But for now, the journey is still in its early stages. The signals from the dark side of the cosmos remain enigmatic, and much work remains to be done to decipher their meaning. The tools we need to study these signals, advanced telescopes, gravitational wave detectors, and quantum sensors, are still in development, but the discovery itself has already set the stage for a new era in the study of the universe. As we continue our exploration of the cosmos, we must keep in mind that the universe is far more complex and mysterious than we ever realized. The dark side of the cosmos is not just a scientific puzzle, It is a philosophical and existential challenge, one that forces us to confront the limitations of our knowledge and our understanding of reality. As we continue to probe the edges of the universe and beyond, we may uncover answers to questions that have haunted humanity for centuries. But we may also find that the journey itself is as important as the destination, leading us to a deeper understanding of the universe, our place within it, and the infinite possibilities that lie ahead. As we dig deeper into the discovery of the dark side of the cosmos, we find ourselves questioning the very foundations of our understanding of the universe. For centuries, scientists have sought to explain the universe's origins, structure, and behavior using models that rely on the assumption that the universe is a self-contained, finite entity. These models, while groundbreaking in their time, are now being stretched to their limits, revealing that the universe we observe may be only a small fraction of the grand cosmic design. The dark side of the cosmos suggests that there are regions of space beyond the edge of the observable universe that we have yet to explore, areas where the very laws of physics may be different from what we know. For decades, scientists have been comfortable with the idea that the universe, though vast, is fundamentally consistent in its structure. The laws of physics, as described by general relativity and quantum mechanics, govern everything from the smallest subatomic particles to the largest galaxies. These laws have served as the bedrock of our understanding of the universe. But the discovery of anomalies in the dark side of the cosmos forces us to consider the possibility that these laws may not be universal. As we continue to study the signals emanating from beyond the observable universe, it's becoming clear that something is amiss in our current understanding. The signals are not only unlike anything we've ever detected before, but they seem to suggest that there are forces at work that we do not yet fully comprehend. These signals, which have been detected by NASA's most advanced telescopes, appear to be coming from regions of space that are beyond the reach of our current observational methods. These areas are not just farther out. These regions may exist in a different dimension or under different laws of physics that we are not equipped to measure. What does this mean for our theories of space-time? General relativity, which describes the behavior of large-scale objects like planets and black holes, has been remarkably successful in explaining much of the universe. Similarly, quantum mechanics, which governs the behavior of particles on the smallest scales, has provided a deep understanding of atomic and subatomic phenomena. But these two pillars of modern physics are not easily reconciled with each other, especially when it comes to explaining phenomena like the nature of dark matter and dark energy, or the behavior of space-time at the edges of the observable universe. The discovery of the dark side of the cosmos suggests that there may be a more fundamental theory of physics that unifies both general relativity and quantum mechanics. Some scientists believe that the elusive theory of quantum gravity, which seeks to explain how gravity works on the quantum level, could hold the key to understanding what's happening in these hidden realms. Quantum gravity could potentially explain how space-time behaves in regions beyond the universe, where the usual laws of physics no longer apply in the same way. One theory that is gaining traction in this field is string theory. String theory proposes that the fundamental building blocks of the universe are not particles, as we have traditionally thought, but tiny vibrating strings of energy. These strings can exist in multiple dimensions beyond the familiar three dimensions of space and one of time that we experience daily. String theory, if proven, could explain not only the dark side of the cosmos, but also the mysteries of quantum gravity and the existence of extra dimensions. If string theory is correct, the universe may not be a three-dimensional space at all, but rather a complex, multi-dimensional construct where space-time itself can bend, fold, and interact with other universes. While string theory remains speculative, it offers a fascinating potential framework for understanding the dark side of the cosmos. If there are extra dimensions beyond the ones we perceive, it could explain why the laws of physics behave differently in the regions we are only just beginning to observe. These dimensions could be influencing the behavior of dark matter and dark energy, pushing the boundaries of our understanding even further. The concept of higher dimensions, dimensions beyond the three spatial ones we experience, has long been a part of theoretical physics. In fact, several theories, such as those proposed by physicist Michio Kaku, suggest that the universe could have as many as 10 or more dimensions. If these dimensions exist, they would be hidden from our senses, too small or too far removed from the space we occupy to detect directly. But in regions beyond the observable universe, these dimensions may have a more direct influence on the structure of space-time. Imagine a universe that is not limited to the 3 dimensions of space we are familiar with, but one that is part of a much larger multidimensional framework. In such a universe, the forces we understand, gravity, electromagnetism, nuclear forces, could be just the tip of the iceberg. There could be other, unknown forces at play, ones that we have yet to detect or even conceive of. The dark side of the cosmos may be where these forces interact, where the unseen dimensions of the universe become visible, and where the laws of physics break down in ways that we cannot yet explain. This idea opens up exciting possibilities for the future of space exploration and scientific discovery. As technology advances, we may one day develop the tools needed to detect these extra dimensions and uncover the forces that lie beyond the observable universe. The signals NASA has detected could be our first clue in a much larger cosmic mystery, one that could lead to the discovery of new dimensions, new laws of physics, and even new forms of matter and energy. At the same time, this discovery raises profound philosophical questions about our place in the cosmos. For centuries, humanity has held to the belief that we occupy a special place in the universe, that the Earth is the center of everything. But if there are other dimensions, other universes, and other forms of reality beyond our own, where does that leave us? Are we just one small piece of a much larger puzzle, a tiny speck in a vast and infinite multiverse? Or do we still hold a unique position in the grand scheme of existence despite the vastness of the cosmos? As we confront these questions, we must also consider the possibility that the universe is not just a collection of random events governed by physical laws, but part of a larger, interconnected system. If other universes exist, and if they interact with our own in ways we cannot yet fully understand, then the very fabric of reality could be far more complex than we ever imagined. The discovery of the dark side of the cosmos is not just a scientific breakthrough. It is a challenge to our deepest assumptions about the nature of existence and the universe itself. The future of space exploration has never looked more exciting. With each new discovery, we push the boundaries of what we thought was possible. The dark side of the cosmos represents the next great frontier, one that promises to reveal new layers of the universe and perhaps even lead us to answers we have been seeking for centuries. But as we venture into this uncharted territory, we must be prepared for the unexpected. The cosmos is far more mysterious, far more complex than we could have ever imagined. The dark side of the cosmos is just the beginning, and what we uncover in the years to come may change our understanding of the universe forever. As we continue to explore the dark side of the cosmos, we begin to realize that the nature of the universe is far more intricate than we could have ever imagined. For centuries, scientists have worked with the assumption that the universe, though vast, is governed by a consistent set of physical laws. These laws, most notably the laws of gravity, electromagnetism, and quantum mechanics, have provided the framework within which we understand the cosmos. But with the discovery of signals from beyond the observable universe, it seems that these laws may not be universal after all. In fact, they may only apply within a specific region of space, our universe. The signals that NASA has detected hint at the possibility that there are forces at play in the dark side of the cosmos that are completely unlike anything we have encountered in our universe. These signals, though still mysterious, appear to be emanating from a region of space where the fabric of space-time behaves in ways that challenge the very core of our understanding. What happens when space-time itself begins to warp and shift in ways we cannot explain? Could it be that the laws of physics break down entirely in the dark side of the cosmos, giving rise to entirely new forms of energy, matter, and even life? At the heart of this discovery is the question of what space-time really is. For centuries, space-time has been understood as a smooth, continuous fabric that is warped by the presence of mass and energy. This idea, first formulated by Albert Einstein in his theory of general relativity, has been one of the cornerstones of modern physics. It explains everything from the motion of planets to the behavior of black holes. But if there are regions of space where the laws of physics break down, then it raises a profound question. Is space-time truly continuous, or is it something much more complex, something that we have yet to fully understand? One of the most compelling theories to emerge from this new understanding of the cosmos is the idea of space-time as a multi-layered structure. According to this theory, space-time may not be a single unified fabric, but rather a complex network of layers, each with its own set of rules and properties. In the dark side of the cosmos, space-time may exist in a form that is radically different from anything we have observed in our universe. This could explain the anomalies we've detected, signals that seem to come from regions of space that operate under entirely different principles. One possibility is that the dark side of the cosmos is governed by a higher dimensional version of space-time. In our universe, we experience space as having three dimensions: length, width, and height, and time as a separate one-dimensional continuum. However, in higher dimensional spaces, there could be additional dimensions of time or even space, each one influencing the behavior of matter and energy in ways that we cannot yet perceive. These extra dimensions may be hidden from our view, existing in a higher realm of reality, but they could still have a profound impact on the universe we observe. If the dark side of the cosmos is a higher dimensional space, it could mean that the forces we are familiar with, gravity, electromagnetism, and the nuclear forces, are just a limited subset of the true range of forces that exist in the cosmos. Just as the three dimensions of space are only a projection of a higher dimensional reality, the laws of physics in our universe could be a projection of more fundamental principles that govern the higher dimensional space beyond the observable universe. This raises a tantalizing possibility. Could the dark side of the cosmos be the key to understanding the deepest mysteries of the universe? If the laws of physics we know are merely a limited subset of a much larger set of principles, what might we discover if we could access these higher dimensions? Could we uncover new forms of energy, new particles, or even entirely new forces that we have not yet imagined? The answers to these questions could have profound implications for everything from space travel to the understanding of dark matter and dark energy. One of the key challenges in exploring the dark side of the cosmos is how to detect and study phenomena that exist beyond the observable universe. For centuries, astronomers have relied on light to study the cosmos. Telescopes have allowed us to see the stars, galaxies, and nebulae that make up the universe. However, light is limited. It can only travel so far, and beyond a certain point, it is no longer visible to us. This is where the concept of gravitational waves comes in. Gravitational waves are ripples in the fabric of space-time caused by the acceleration of massive objects, such as colliding black holes or neutron stars. These waves travel at the speed of light, but they can carry information about events that are invisible to regular telescopes. By detecting and studying gravitational waves, scientists hope to gain new insights into the hidden realms of the universe, including the dark side of the cosmos. The detection of gravitational waves has already opened up a new way of observing the universe. In 2015, scientists at LIGO, Laser Interferometer Gravitational Wave Observatory, made the groundbreaking discovery of gravitational waves from the collision of two black holes. This discovery confirmed a major prediction of Einstein's general theory of relativity and marked the beginning of a new era in astrophysics. But while gravitational waves have provided new insights into the nature of space-time, they also present a unique challenge. How do we detect waves that originate from beyond the observable universe, in regions where the laws of physics may be radically different? One possible solution lies in the study of quantum fluctuations. Quantum mechanics, which governs the behavior of particles on the smallest scales, suggests that space-time is not smooth and continuous, but rather granular and fluctuating. These fluctuations, which occur on the smallest scales of the universe, could be responsible for the strange signals we've detected coming from the dark side of the cosmos. By studying these quantum fluctuations, scientists may be able to gain new insights into the nature of space-time and the hidden dimensions of the cosmos. But even as we develop new tools to study the dark side of the cosmos, we must also confront the philosophical implications of this discovery. If the dark side of the cosmos is a higher dimensional space, what does that mean for our understanding of reality itself? How do we reconcile the idea of multiple dimensions with the familiar three-dimensional world we experience? If the laws of physics are different in the dark side of the cosmos, does that mean that our universe is just one version of reality, a single slice of a much larger cosmic structure? These questions push the boundaries of science and philosophy, inviting us to rethink everything we thought we knew about the universe. The dark side of the cosmos challenges our most fundamental assumptions about space, time, and reality. It forces us to consider the possibility that our universe is not the center of everything, but just one part of a much larger and more complex reality. As we continue to explore the dark side of the cosmos, we may discover that the universe is far more interconnected and dynamic than we ever realized. The signals from beyond the observable universe are just the beginning, and what we learn in the coming years could forever change our understanding of the cosmos. The journey into the dark side of the cosmos is just beginning, but it promises to be one of the most exciting and transformative periods in the history of science. As we push the boundaries of human knowledge, we may uncover truths that will redefine everything we know about the universe and our place within it. The exploration of the dark side of the cosmos is not just a scientific endeavor, it is a journey into the very nature of existence itself. As we stand on the edge of this extraordinary new era in cosmology, one of the most profound revelations brought forth by the discovery of the dark side of the cosmos is the potential for new insights into the very origins of the universe. For decades, scientists have speculated about the conditions that existed before the Big Bang, the event that set the cosmos into motion. But with the discovery of signals emanating from beyond the observable universe, we are beginning to glimpse the possibility that the answers we seek may lie in realms of space and time that were once thought to be beyond our reach. These discoveries have the potential to reshape not only the field of cosmology, but also our understanding of the origins of existence itself. The conventional understanding of the Big Bang theory suggests that the universe began as an infinitely dense and hot point, a singularity that expanded rapidly, giving rise to the space and time we now experience. This event is thought to have occurred roughly 13.8 billion years ago, marking the birth of the observable universe. But while this theory has provided us with a compelling explanation for the expansion and evolution of the universe, it leaves many questions unanswered, particularly regarding the nature of the space-time fabric itself and what came before the Big Bang. One of the key aspects of the dark side of the cosmos is the possibility that it could provide insight into the pre-Big Bang era. For the first time, we may have the opportunity to study regions of space that exist outside of our observable universe, potentially revealing information about the conditions that existed before the Big Bang. What did the universe look like before this event? Was there a time when space and time themselves did not exist, or did they emerge gradually from some deeper reality? These are the kinds of questions that have baffled cosmologists for generations, and the discovery of the dark side of the cosmos may be the key to answering them. To understand the significance of this discovery, we must first consider the nature of the space-time continuum. The space-time continuum, as described by Einstein's theory of general relativity, is a four-dimensional fabric that combines the three dimensions of space with the dimension of time. This framework has been incredibly successful in explaining the motion of planets, the behavior of light, and the effects of gravity. However, when we look beyond the observable universe into regions where the normal rules of physics appear to break down, the very nature of space-time itself becomes uncertain. Some theories, such as those proposed by physicist Stephen Hawking and others, suggest that space and time may not have had a definite beginning. Instead, they could have emerged from a deeper, more fundamental layer of reality, a concept often referred to as quantum gravity. According to these theories, the Big Bang might not have been the beginning of everything, but rather the transition from one state of reality to another. Before the Big Bang, space and time may not have existed in the way we understand them now. In fact, some theories suggest that the early universe was a quantum state in which space and time were highly unstable, with the laws of physics as we know them not yet fully formed. If the dark side of the cosmos is a region where the usual laws of physics no longer apply, it could be a glimpse into this pre-Big Bang state. The signals we've detected could be offering us a view of the universe before the Big Bang, or perhaps even a view of the forces that created the Big Bang itself. These forces, operating in the dark regions beyond the universe, may have been the spark that ignited the cosmic expansion that led to the formation of galaxies, stars, and planets. But the questions raised by this discovery are not just scientific, they are deeply philosophical as well. If the universe didn't have a definite beginning, what does that mean for our understanding of existence? For centuries, humans have searched for the origin of everything, seeking to understand why the universe exists at all. But if the Big Bang was not the beginning, and if the dark side of the cosmos holds the key to understanding what came before it, then we must reconsider the very nature of creation itself. Is the universe simply a part of an infinite cycle, where new universes are constantly being born, evolving and dying? Or is there some deeper, more mysterious force at play that drives the continuous emergence of space and time? These questions force us to reconsider the limits of human knowledge. For generations, we have believed that the observable universe is the entirety of existence, that everything we see, touch, and experience is all that is real. But with the discovery of the dark side of the cosmos, we are now faced with the possibility that our perception of reality is far more limited than we ever imagined. There may be realms of existence that are beyond our senses, beyond our comprehension, and yet they shape the universe in ways we cannot fully understand. As we continue to investigate the dark side of the cosmos, it becomes clear that the search for the origins of the universe is not just a matter of studying distant galaxies or observing cosmic phenomena. It is a journey into the very heart of reality itself, a quest to understand the fundamental forces that shape space, time, and existence. And as we push the boundaries of what we know, we are confronted by the humbling realization that there is still so much more to learn. In the coming years, scientists will likely develop new tools and techniques to explore these hidden regions of space. Advanced telescopes, quantum sensors, and gravitational wave detectors will allow us to peer deeper into the dark side of the cosmos, uncovering new layers of the universe that were previously invisible. These instruments may reveal entirely new forms of matter, energy, and force, phenomena that could change our understanding of everything from the structure of galaxies to the origins of life. But the journey into the dark side of the cosmos is not just about discovery. It is also about redefining our place in the universe. For centuries, humanity has seen itself as the center of the universe, the pinnacle of creation. But as we look beyond the observable universe, we are forced to confront the possibility that we are just one small part of a much larger, more complex reality. We are part of a cosmic web that stretches across multiple dimensions and realms, each one interacting with the others in ways we have yet to comprehend. Our existence, while unique, is part of a much grander cosmic story, one that spans not just the universe, but the entirety of reality itself. The dark side of the cosmos, as unsettling as it may be, offers us a glimpse into the deeper mysteries of the universe. It challenges our most basic assumptions about space, time, and reality, and forces us to ask the big questions, questions that have plagued humanity for centuries. What is the true nature of existence? Where do we come from, and where are we going? These are the questions that drive our curiosity and our thirst for knowledge. And as we continue our journey into the unknown, we may find that the answers are more extraordinary than we could have ever imagined. The road ahead is long, and the discoveries that lie ahead may challenge everything we know about the universe. But one thing is certain: the dark side of the cosmos holds the key to understanding not just the universe, but the very nature of existence itself. As we push the boundaries of human knowledge and explore new frontiers, we are opening a door to a future filled with unimaginable possibilities, possibilities that could forever change the course of science, philosophy, and our understanding of life. As we continue our exploration of the dark side of the cosmos, we find ourselves faced with the realization that this discovery is far more than a scientific breakthrough. It is a paradigm-shifting moment that challenges our deepest assumptions about the universe. The more we learn about the regions beyond the observable universe, the more we are forced to confront the limitations of our knowledge and the complexities of reality itself. One of the most profound aspects of this discovery is the possibility that the dark side of the cosmos holds clues to understanding the very structure of space-time. For centuries, physicists have relied on a set of fundamental principles to explain the workings of the universe. These principles, governed by the laws of general relativity and quantum mechanics, have provided us with a remarkable understanding of everything from the behavior of galaxies to the interactions of subatomic particles. But now, with the detection of anomalies beyond the observable universe, we are faced with the prospect that these laws may not apply universally. At the heart of this challenge lies the very nature of space-time itself. Space-time, as described by Einstein's general theory of relativity, is a fabric that is warped by the presence of mass and energy. This warping of space-time is what gives rise to the force of gravity, and it governs everything from the orbits of planets to the formation of black holes. For centuries, this model has served as the cornerstone of our understanding of the universe. However, the discovery of signals from the dark side of the cosmos suggests that space-time may not be as stable and predictable as we once thought. Could it be that space-time itself is far more complex, more dynamic than we ever imagined? The dark side of the cosmos could hold the key to answering this question. If the laws of physics break down in regions beyond the observable universe, it suggests that space-time may be more malleable than we have assumed. This idea is not just speculative, it is grounded in the latest research in quantum gravity, a field that seeks to reconcile general relativity with the principles of quantum mechanics. Quantum gravity, still in its infancy, proposes that space-time is not a smooth, continuous fabric, but rather a granular, fluctuating structure that operates on the smallest scales. In this view, the fabric of space-time is made up of discrete units, quantum grains of space and time. If this theory is correct, it could explain why the dark side of the cosmos behaves in ways that are completely different from what we observe in our own universe. It could also provide insight into the origins of space-time itself, how the universe began, and why the laws of physics work the way they do. But what exactly does this mean for the structure of the universe beyond our observable horizon? One possibility is that the dark side of the cosmos could be a higher dimensional realm, one that operates according to a different set of physical laws. The concept of extra dimensions has been proposed by several theories in theoretical physics, most notably string theory, which posits that the universe is made up of tiny, vibrating strings that exist in more than the familiar three dimensions of space. These extra dimensions could be hidden from our perception, existing at scales so small that they are undetectable with current technology. If the dark side of the cosmos is part of a higher dimensional space, it could mean that what we perceive as empty space is actually filled with invisible dimensions, dimensions that influence the very structure of space-time itself. This idea of a higher dimensional space challenges our very conception of the universe. For centuries, we have understood space-time as a four-dimensional continuum with 3 dimensions of space and 1 of time. But what if this is only a projection of a much larger, multi-dimensional reality? If the dark side of the cosmos is part of a higher dimensional space, it could explain many of the anomalies we have detected. It could also provide a new framework for understanding phenomena like a dark matter and dark energy, which make up the majority of the universe's mass and energy, but remain invisible to our current instruments. The discovery of the dark side of the cosmos also raises the tantalizing possibility that we are not the only ones in the universe. If the dark side is home to other dimensions, there may be forms of life and intelligence that exist in these realms. These life forms could be vastly different from anything we have ever imagined, evolving under different physical laws, existing in environments that are incomprehensible to us. The idea that there could be life beyond our universe is both awe-inspiring and unsettling. If life exists in other realms, what are the chances that we might one day make contact with these civilizations? This prospect is still speculative, but it raises the exciting possibility of a vast, interconnected web of universes, each with its own versions of life, consciousness, and reality. If we accept the idea that the dark side of the cosmos is a higher dimensional space, it could mean that our universe is part of a much larger multiverse, a collection of parallel realities that coexist alongside our own. These parallel universes could be governed by completely different laws of physics, where the fundamental forces of nature work in ways that are completely alien to us. However, the question remains, how do we study these hidden realms? How do we detect signals from universes that exist beyond our reach? This is where the latest advancements in observational technology come into play. As our instruments become more advanced, we may be able to detect traces of these other dimensions. Gravitational wave detectors, for example, allow us to measure the ripples in space-time caused by massive objects like black holes. These waves travel through the universe, carrying information about the events that created them. If there are higher dimensional forces at work in the dark side of the cosmos, it is possible that gravitational waves from these realms could be detected as well. In addition to gravitational waves, scientists are also exploring the use of quantum entanglement as a potential tool for studying the dark side of the cosmos. Quantum entanglement is a phenomenon in which particles become linked in such a way that their properties are instantaneously correlated, no matter how far apart they are. Some scientists speculate that quantum entanglement could be used to study hidden dimensions, allowing us to observe the interactions between universes in a way that is currently impossible with traditional methods. As we continue to explore the mysteries of the dark side of the cosmos, it is clear that we are entering a new era of discovery, one that will challenge everything we thought we knew about the universe and our place within it. The dark side of the cosmos is not just a scientific mystery. It is a philosophical and existential challenge that forces us to confront the very nature of reality. The discovery of hidden realms beyond the universe will reshape the way we think about space, time, and existence itself. As we venture deeper into the unknown, we must also ask ourselves, what is our role in this vast cosmic landscape? Are we just one small piece of an infinite puzzle, or is there something more profound at play? The dark side of the cosmos may hold the key to unlocking the deepest mysteries of existence, and the answers we seek could change the way we perceive the universe forever. As we delve deeper into the mystery of the dark side of the cosmos, it becomes evident that this discovery has far-reaching implications for not just our understanding of space and time, but for the very essence of reality itself. The questions this discovery raises extend far beyond the realm of astrophysics. If the boundaries of the universe we know are not the true limits of reality, then what does that say about the nature of existence? Could it be that the laws of physics that govern our world are just one version of the truth, one set of rules in an infinite expanse of possibilities? One of the most profound questions that arises from the discovery of the dark side of the cosmos is the possibility that the universe we inhabit is not unique. The concept of the multiverse has long been a theoretical idea, discussed in academic circles but dismissed by many as speculative fiction. However, the signals NASA has detected seem to suggest that the dark side of the cosmos could be linked to the existence of other universes, each with its own set of laws and structures. This idea, while still speculative, is beginning to gain traction among some of the brightest minds in physics and cosmology. If multiple universes do exist, each one could operate according to different physical principles, making the very nature of space and time malleable and subject to change. This possibility opens up new realms of inquiry, one that stretches the boundaries of science and challenges our most fundamental assumptions about the universe. For example, if there are parallel universes, what does this mean for the laws of physics that we have always relied on? Could the laws of gravity, electromagnetism, and quantum mechanics be different in other realms? And if these universes are interacting with one another in ways we cannot yet perceive, what effects could they have on the space-time fabric of our own universe? One of the key pieces of evidence pointing to the existence of parallel universes is the phenomenon known as quantum fluctuations. Quantum mechanics, the branch of physics that governs the behavior of particles at the smallest scales, tells us that space and time are not as solid and stable as we once thought. Instead, they are in a constant state of fluctuation, with particles popping in and out of existence and the very fabric of space-time bending and warping on the smallest scales. Some scientists believe that these fluctuations could provide a bridge between universes, allowing them to interact and even influence one another. The discovery of the dark side of the cosmos has provided the first tangible evidence that these quantum fluctuations may be more than just theoretical. They may be the key to understanding how parallel universes could exist and interact with our own. If quantum fluctuations are not limited to our universe, but extend into other realms, then the possibility of inter-universal interaction becomes much more plausible. In this view, the dark side of the cosmos is not just a mysterious region of space, but a gateway to a vast multiversal structure where universes interact in ways that we have yet to fully comprehend. However, the idea of parallel universes and quantum fluctuations is still highly speculative. While the mathematical models are intriguing, we have yet to develop the observational tools necessary to directly detect these other realms. The signals NASA has detected from beyond the observable universe could be the first clue that we are not alone in this reality, but they are far from definitive proof. In order to confirm the existence of other universes, scientists will need to develop new technologies, advanced telescopes, quantum sensors, and gravitational wave detectors that can probe deeper into the fabric of space-time than ever before. One promising avenue for exploration is the study of gravitational waves. Gravitational waves, as predicted by Einstein's theory of general relativity, are ripples in space-time caused by the acceleration of massive objects. These waves travel at the speed of light and carry information about the events that produce them, such as the collision of black holes or the merger of neutron stars. In recent years, scientists have made significant breakthroughs in the detection of gravitational waves, opening up a new way of observing the universe. But if there are multiple universes, gravitational waves from other realms could offer us a glimpse into the structure and behavior of these parallel worlds. In addition to gravitational waves, scientists are also exploring the potential of quantum entanglement as a tool for detecting parallel universes. Quantum entanglement is a phenomenon in which particles become linked in such a way that their properties are instantaneously correlated, no matter how far apart they are. Some researchers speculate that quantum entanglement could provide a way to detect interactions between universes, revealing connections between distant realms that were previously hidden from our view. If entangled particles can bridge the gap between parallel universes, they may offer a new way to study the dark side of the cosmos. As we push the boundaries of our observational capabilities, it is also important to consider the potential implications of discovering that our universe is not unique. If the dark side of the cosmos is part of a multiverse, it could suggest that the universe we live in is just one of many, each with its own distinct characteristics. This would challenge the anthropocentric view that humanity occupies a central place in the cosmos. In a multiverse, we are not the center of all reality. Rather, we are just one part of an infinitely complex and interconnected web of universes, each with its own history, structure, and laws. For many, this realization is both humbling and awe-inspiring. The idea that there are infinite versions of reality, each one a unique and distinct expression of the laws of physics, forces us to reconsider the nature of existence itself. Are we just a tiny part of a much larger and more complex cosmic story? Or is there something truly unique about our universe and our place within it? These are questions that have plagued philosophers and scientists for centuries, and the discovery of the dark side of the cosmos could provide new insights into these age-old mysteries. But the implications of this discovery are not just philosophical, they are practical as well. If the laws of physics vary from one universe to another, it could mean that we are living in a universe with a unique set of conditions that allow life to exist. This idea, known as the fine-tuning argument, suggests that the universe's physical constants, such as the strength of gravity, the mass of particles, and the speed of light, are perfectly calibrated to support the existence of life. If the dark side of the cosmos is part of a larger multiverse, it could mean that life, as we know it, is an unlikely and precious occurrence, dependent on the precise configuration of physical laws in our particular universe. This realization has profound implications for the search for extraterrestrial life. If there are other universes, could there be life forms existing in these parallel realms, operating under different physical laws and conditions? What would it mean for humanity if we were to make contact with an advanced civilization from a parallel universe, one that exists in a reality governed by completely different principles? As we continue to explore the dark side of the cosmos, we are not just searching for answers about the nature of the universe. We are searching for answers about ourselves. What is our place in this vast and interconnected multiverse? Are we alone, or are we part of a greater cosmic story that extends far beyond our universe? These are the questions that will drive scientific inquiry and philosophical debate for generations to come. The discovery of something beyond our universe is not just a scientific breakthrough. It is a revelation that forces us to rethink the very nature of existence and our role within it. As the dark side of the cosmos continues to reveal its mysteries, we begin to encounter more questions than answers. The discovery that something exists beyond the observable universe has forced scientists to reframe the entire concept of what constitutes reality. For centuries, we have understood the universe as the sum total of existence, an infinite expanding expanse of space and time governed by the laws of physics. Yet, this new frontier, the dark side of the cosmos, suggests that our universe may not be the only realm that exists, but rather just one of many, and that what we know as the universe is merely a slice of something far larger and more complex. One of the most fascinating implications of this discovery is the suggestion that the boundaries of the universe, as we know them, are not as fixed as we once believed. If the laws of physics break down in the regions beyond the observable universe, it means that space and time may not be the rigid, unchanging constructs we thought they were. Instead, they may be fluid, dynamic, and far more complex than we can currently understand. The idea that space and time could be malleable challenges the very essence of what we know about the cosmos and opens up new questions about the true nature of reality. One of the key concepts that scientists are grappling with is how to understand space-time beyond the observable universe. Space-time, the four-dimensional fabric that unites space and time, has been a cornerstone of our understanding of the universe. But if space-time behaves differently beyond the edge of the observable universe, as the signals suggest, then our understanding of its nature must be revised. Could it be that space-time is not just a passive, unchanging backdrop, but an active, dynamic force that can be influenced by factors beyond our comprehension? Theories such as string theory and quantum gravity offer potential explanations for what is happening in these regions of the cosmos. String theory, for instance, posits that the fundamental building blocks of the universe are not point-like particles, but tiny, vibrating strings. These strings exist in more than the familiar three dimensions of space and one of time, proposing that the universe operates on multiple dimensions, some of which are hidden from our perception. If these extra dimensions exist, they could play a crucial role in the behavior of space-time itself, especially in regions beyond the observable universe where the laws of physics appear to break down. Quantum gravity, another field of research, seeks to merge the principles of quantum mechanics with those of general relativity. Quantum mechanics governs the behavior of particles on the smallest scales, while general relativity explains the large-scale structure of the universe, including the behavior of black holes and galaxies. However, these two theories are incompatible when applied to extreme conditions, such as the center of black holes or the early moments of the Big Bang. Quantum gravity aims to create a unified theory that can explain the behavior of spacetime at both the smallest and largest scales. If quantum gravity holds the key to understanding the dark side of the cosmos, it could provide the framework we need to study regions of space that have remained hidden from us. But beyond the scientific questions, the discovery of the dark side of the cosmos raises deeper philosophical and existential issues. If the universe we observe is just one of many parallel realities, each with its own set of physical laws, what does that mean for our understanding of life itself? Are we the only forms of life in existence, or are there countless other civilizations, each evolving under a different set of cosmic conditions? What does it mean for humanity if we are not the center of the universe, but one small part of an infinite multiverse? This realization is both humbling and awe-inspiring. For centuries, humans have searched for meaning in the cosmos, looking to the stars and wondering if there is life beyond Earth. The discovery of parallel universes suggests that we are not alone in the cosmos, but part of an interconnected web of realities, each with its own version of life, consciousness, and existence. This raises the question, what is the nature of life in a multiverse? How does it differ from the life we know, and what are the possibilities for discovering new forms of existence in parallel realms? If the dark side of the cosmos is a gateway to other universes, it could mean that we are on the verge of a profound breakthrough in our understanding of life and consciousness. Could there be life forms in other universes that are radically different from anything we can imagine? Could there be civilizations that have developed entirely new forms of technology, energy, or communication? What would it mean for humanity if we were to encounter these beings? The potential for contact with civilizations from other universes is a tantalizing possibility, one that challenges the very notion of isolation in the cosmos. But beyond the discovery of life in parallel universes, the dark side of the cosmos invites us to reconsider the very nature of our reality. If there are regions of space where the laws of physics do not apply in the same way, then our understanding of what is real becomes fluid. Could it be that reality is not a fixed, immutable construct, but rather a malleable force influenced by the fabric of space-time itself? Could the universe be a vast, interconnected web of realities, each one shaped by different laws and principles, existing side by side, yet invisible to one another? If this is true, then the discovery of the dark side of the cosmos may be just the beginning of a larger, more complex story, one that could stretch the boundaries of human understanding far beyond what we ever imagined possible. The idea that the universe we observe is only one of many challenges our fundamental assumptions about existence. For centuries, humans have thought of the universe as a self-contained entity, a vast, infinite space governed by a consistent set of laws. But the discovery of the dark side of the cosmos forces us to confront the possibility that the universe is not isolated, but part of a much larger, multi-dimensional reality. This realization reshapes our view of the cosmos and forces us to ask, what does it mean for us to exist in a universe that is not the only one? Are we just one small part of an infinite cosmic story, or is there something unique about our universe and our place within it? As we continue to explore the dark side of the cosmos, we must confront these questions, knowing that the answers we seek may forever alter our understanding of reality. The discovery of something beyond the universe is not just a scientific breakthrough, it is a philosophical awakening. It forces us to reconsider our place in the cosmos and to rethink the very nature of existence. And as we venture deeper into the unknown, we are reminded that the journey of discovery is never truly over. Every new question opens the door to more mysteries, more wonders, and more possibilities. The dark side of the cosmos is just one chapter in the ongoing story of humanity's quest for knowledge, and the answers we find may be more extraordinary than we can imagine. As we move forward with our exploration of the dark side of the cosmos, the questions we are facing are becoming more profound, and the answers seem to stretch beyond our current scientific and philosophical understanding. What we once thought of as the ultimate boundary, the observable universe, has now been revealed to be just a fraction of an infinite and complex multiverse. The discovery of signals from regions beyond this boundary is only the beginning of an intellectual and existential journey that will take us to the farthest reaches of human knowledge. One of the most tantalizing aspects of this discovery is the concept of other universes, or parallel realities. For centuries, we have operated under the assumption that the universe we observe is the totality of existence, that it is the sum of all that is. But now, with the realization that there may be universes beyond our own, we are confronted with the possibility that our universe is just one among many. This multiverse theory proposes that our reality, with its specific set of physical laws and constants, is only one of many that coexist in a much larger structure. Each universe could have its own rules, its own version of space-time, and potentially even its own forms of life and consciousness. If multiple universes exist, this raises profound questions about the nature of reality and our place within it. Are we special, or are we just one small part of an infinite number of universes, each with its own version of reality? Does this mean that the laws of physics that govern our world, gravity, electromagnetism, and quantum mechanics, are just one version of a larger, more intricate set of rules? Could there be other realms where time flows differently, or where life forms evolve in ways we cannot even begin to imagine? The implications of the multiverse theory extend beyond the realm of physics and astronomy, touching on the very nature of existence itself. If there are infinite universes, does that mean that all possibilities are realized somewhere? In one universe, perhaps we are living the life we know. In another, we might be leading an entirely different existence. Could the existence of multiple versions of ourselves in parallel universes offer insight into the nature of free will, fate, and the choices we make in our lives? For example, if the concept of parallel realities holds true, what would it mean for our understanding of identity? Are we merely one expression of our consciousness, or could there be countless versions of us existing simultaneously in different universes, each making different decisions and living out alternate paths? The discovery of the dark side of the cosmos challenges the idea of a single linear path of existence and instead opens the door to an infinite number of potential realities. This concept pushes the boundaries of our understanding of self, identity, and consciousness, suggesting that what we perceive as us may not be limited to the reality we currently occupy. Another aspect of the multiverse theory is the potential for different forms of life to exist in these parallel universes. Just as the laws of physics could differ from one universe to another, so too could the conditions that allow life to arise. In some universes, life could exist in forms that are completely alien to us, life forms that do not rely on carbon-based chemistry or that evolved under entirely different conditions. These beings might not be made of atoms or molecules, but could exist in entirely unknown forms, challenging our very definitions of life and consciousness. The discovery of the dark side of the cosmos raises another critical question. Could there be a way to connect with these parallel universes? Could we, with the right tools or technology, make contact with the beings that inhabit other realities? The idea of inter-universal communication might sound like science fiction, but if the multiverse theory holds, then it's possible that there are methods we have yet to discover that could bridge the gap between universes. If quantum mechanics can indeed be extended to describe interactions between parallel universes, we might one day develop technologies capable of accessing these realms and even interacting with them. This idea of inter-universal communication invites us to reconsider the very nature of space and time. In our current understanding, space and time are the backdrop against which all events occur. But in a multiverse, where different universes could operate under their own distinct laws, space and time may not be fixed. Instead, they may be more fluid, more interconnected, and perhaps even interdependent across parallel realities. This suggests that the very fabric of spacetime is far more complex and dynamic than we could have imagined. Perhaps one of the most profound questions raised by the discovery of the dark side of the cosmos is the nature of reality itself. What is real? We have always considered our universe to be the only reality, the only truth, and the only version of existence. But what if this is only one layer of a much greater cosmic structure, one that includes infinite other realities, each with its own version of truth, space, and time? In this context, our universe is not the center of all existence, but a small part of a much grander and more complex multiverse. This challenges the anthropocentric view of the universe that has defined human thought for centuries, pushing us to reframe our perception of reality. The question of reality also extends to the nature of consciousness itself. In a multiverse, consciousness might not be limited to our universe or our particular set of physical laws. Could there be other forms of consciousness that exist outside of our universe? Could there be beings with different kinds of awareness, different modes of perception, and different understandings of existence? As we explore the dark side of the cosmos, these questions become more pressing, and the need to redefine our concepts of self and consciousness becomes more apparent. As we continue to probe the dark side of the cosmos, we must acknowledge that the journey we are embarking on is one that transcends scientific discovery alone. It is a journey that will challenge our most fundamental beliefs about space, time, existence, and consciousness. The implications of the discovery are not just scientific or intellectual, they are deeply personal and existential. If we are part of a vast multiverse, where does that leave us as individuals? What does it mean for us to exist in a reality that is not the only one, but part of a far larger cosmic story? The dark side of the cosmos, as mysterious and elusive as it may be, is forcing humanity to confront the vastness of existence in a way we have never done before. As we look beyond the observable universe and explore the signals emanating from beyond its boundaries, we are discovering a reality that is more complex, more interconnected, and more awe-inspiring than we ever imagined. And with each new discovery, we are inching closer to uncovering the deepest mysteries of the cosmos and our place within it. The answers we seek may not be easy to find, but they are worth pursuing. The journey to understand. The dark side of the cosmos is not just about uncovering new scientific knowledge. It is about expanding our understanding of existence, consciousness, and the very nature of reality. As we continue to explore, we are bound to encounter more questions, more enigmas, and more wonders. And with each new discovery, we will inch closer to understanding the true nature of the universe and the infinite possibilities that lie beyond it. As we reach the final chapter of this extraordinary exploration into the dark side of the cosmos, the questions we have encountered throughout our journey have forced us to reimagine not only the nature of the universe, but also our place within it. The discovery of signals from beyond the observable universe has opened a new frontier of scientific inquiry and philosophical reflection, one that challenges the very foundations of human understanding. We are no longer simply observers of a vast and unchanging cosmos. We are part of an infinitely complex and interconnected reality, one that spans beyond the limits of our comprehension. One of the most profound revelations to emerge from the study of the dark side of the cosmos is the realization that our universe may not be the only one. The multiverse theory, once considered speculative, is now gaining serious consideration as a possible framework for understanding the nature of reality. If multiple universes exist, each with its own set of physical laws and principles, then the universe we inhabit is just one piece of a much larger cosmic structure. The dark side of the cosmos may be the key to understanding this vast interconnected multiverse, a network of realities that coexist and interact in ways we are only beginning to understand. This concept of the multiverse is as humbling as it is awe-inspiring. For centuries, humanity has believed that we occupy a central, unique position in the cosmos. The Earth has long been considered the pinnacle of creation, and the universe we observe has been viewed as the totality of existence. But the discovery of something beyond the observable universe forces us to reconsider this anthropocentric view of reality. We are not the center of everything. We are one small piece of an infinitely complex cosmic web, and our universe is just one of many. This realization challenges our understanding of space, time, and existence itself, and forces us to confront the possibility that the nature of reality is far more intricate and mysterious than we ever imagined. The implications of the dark side of the cosmos extend far beyond the realms of science. As we contemplate the existence of parallel universes, each with its own set of laws and conditions, we are prompted to ask profound existential questions. If multiple universes exist, what does that mean for our understanding of life and consciousness? Are we unique in our capacity for thought and awareness, or is consciousness a fundamental aspect of all realities, a force that transcends the boundaries of individual universes? Could there be other forms of life out there, life that has evolved under completely different conditions, in universes governed by laws we cannot even imagine? These questions touch on the very essence of what it means to be human. For centuries, we have sought meaning and purpose within the confines of our universe. We have looked to the stars for answers about our origins, our destiny, and the nature of existence. But now, with the discovery of the dark side of the cosmos, we are forced to confront the possibility that our search for meaning may be part of a much larger and more complex story, a story that spans across multiple dimensions and realities. The answers we seek may not be found within the universe we know, but in the vast, interconnected expanse of the multiverse. As we continue to study the signals from beyond the observable universe, we are also faced with the challenge of developing new tools and technologies to explore these hidden realms. The limits of our current observational instruments, telescopes, particle accelerators, and quantum sensors are becoming more apparent as we push the boundaries of what we know. To truly understand the nature of the dark side of the cosmos, we will need to develop new techniques for detecting and studying the phenomena that lie beyond our current observational reach. Gravitational wave detectors, quantum entanglement experiments, and other cutting-edge technologies will be essential in unlocking the secrets of the dark side of the cosmos. But while the technology is crucial, so too is the way we approach the study of the dark side of the cosmos. This discovery forces us to rethink the way we conduct scientific inquiry. For years, we have been content to study the universe from the outside, looking in from the safety of our position on Earth. But now, with the possibility of other universes existing alongside our own, we must approach the cosmos from a more holistic perspective. We must embrace the idea that the universe is not an isolated system, but part of a larger, more interconnected whole. This requires a shift in our approach to science, one that acknowledges the complexity of reality and the possibility of infinite dimensions and parallel universes. As we push forward into this uncharted territory, we must also confront the ethical and philosophical questions that arise from the discovery of the dark side of the cosmos. What responsibility do we have as a species in this larger cosmic context? If there are other forms of life out there, potentially living in parallel universes, how do we approach them? Are we prepared for the implications of discovering extraterrestrial civilizations? Or are we still too focused on our own survival and advancement to consider the broader, interconnected nature of existence? These are questions that humanity will need to grapple with as we continue to explore the cosmos and expand our understanding of reality. The journey into the dark side of the cosmos is not just about uncovering the mysteries of the universe, it is also about understanding ourselves. As we venture into the unknown, we are forced to confront our place in the cosmos and the nature of existence itself. The discovery of something beyond the observable universe challenges our sense of self-importance and forces us to reckon with the fact that we may be just one small piece of an infinite cosmic puzzle. But it also offers us the opportunity to expand our understanding of life, consciousness, and the very fabric of reality. With every new discovery, we come closer to unlocking the mysteries of the cosmos. The signals from beyond the observable universe are just the beginning. What lies ahead could change the course of human history. As we continue to push the boundaries of science and explore the dark side of the cosmos, we are reminded that the universe is far more complex, far more wondrous than we ever imagined. And the journey into the unknown, though fraught with challenges and uncertainties, offers the promise of discoveries that could transform our understanding of everything we know about space, time, and existence itself. In the end, the discovery of the dark side of the cosmos is not just a scientific breakthrough, it is a call to adventure, a call to expand our horizons and reach beyond the boundaries of our understanding. The answers we seek may be far from simple, but they hold the key to unlocking the deepest mysteries of the universe, and perhaps even the very nature of life itself.